Hi, this is Paris Wolf teaching cryptography. Make sure you smash that subscribe button, like, and comment any questions below. We're going to take a look at the different cipher modes here, starting with electronic codebook, which is the weak and the most unsecure mode. So block 1 here, this represents the plain text data, and this is going to go through an encryption algorithm, such as advanced encryption standard, creating the cipher 1 text. What you need to know about electronic codebook is that each block of data is going to be processed separately, so they're independent of each other. And if the same input or plaintext data is put into the block and then encrypted with the same algorithm, then the cipher is always going to be the same. It is weak against copy and paste attacks, and that's when the attacker could copy and paste the cipher blocks from one part of the message to another. And if the attacker observes identical ciphertext blocks in different parts of the messages, it indicates that the corresponding plaintext blocks are identical. With cipher block chaining, this one's a little bit different. We have the block 1 plaintext data, and that gets XORed through the initialization vector with one of these processes, XOR and or, and then it gets encrypted. Now this one here is a lot different because after it gets encrypted, cipher 1 is now used as the initialization vector for the next block of data. So block 2 is now going to XOR the cipher 1, and then that's going to get encrypted, creating cipher 2, and then cipher 2 is going to go to block 3, and block 3, or the data set 3, is going to get XORed with cipher 3 with the encryption, and then putting out output cipher 4, and so on until the end of the message. Now, this initialization vector, this goes back to the math in bits here. So block 1 represents the data, and the second set sets up the initialization vector, and then the output. This is what's getting encrypted here with the encryption algorithm. So you just really need to know that the cipher block chaining incorporated the initialization vector, and the definition of the process would be uses an initialization vector to encrypt the first block. It's randomly created this first set initialization vector, and then uses the results of that encryption cipher to encrypt the next block. I do want to note that the initialization vector has to be sent with the ciphertext in order for it to be decrypted. The first step for cipher feedback is the initialization vector, which is randomly generated or created. That initialization vector then gets encrypted with an algorithm such as advanced encryption standard, and then the output of that is XORed. Now, this XOR has multiple different outputs. One output goes with block 1 and creates that self-synchronizing stream, creating cipher 1. The other output, they're going to take a portion of that XOR process, and that's fed into the next block here, use it as the initialization vector, then that then gets encrypted and then streamed with block 2, and that process goes on forever. So what you really need to know about cipher feedback is that it's a self-synchronizing stream cipher, and it takes the current block output of the XOR process and is using that as the initialization vector. The definition would be a self-synchronizing stream on the blocks where the initialization vector is encrypted and XORed with the data stream. Output feedback is almost the same as cipher feedback mode. It generates this initialization vector, which is then encrypted with an advanced encryption standard or any encryption algorithm. And however, the difference is it takes that output from the cipher stage and uses that as the initialization vector for the next set of data, while the other portion of the output continues to get XORed, and because it's a stream one by one with this block 1, creating this cipher 1, while the output over here from the cipher stage is used as the initialization vector. Now the cipher mode, the counter, that is when it's converting a block into a stream cipher, but it's using a counter value and a nonce. A nonce is a random number that's generated once. So with block 1, the counter starts at 0, and then for each additional block, the counter just keeps raising by 1, and each block is going to be completely independent of each other, allowing for parallel processing. So when the hardware is receiving all of this data, if you have multiple processors, it's able to decrypt that information a lot faster.